This conference will now be recorded.
Hello friends, today we are going to see DNS, the topic of our fourth unit. DNS stands for Domain Name System. Second point inside the slide is to locate any object address. Now normally when we talk about any location of any device or a place, normally the thing is we need an address to point out to that particular device or a thing. Now the purpose of naming is to locate any object. Address is required. Okay. Theoretically, we refer to web pages, mailboxes, and other resources by using the network addresses of computers, that is IP. Names are easier to access the address. It means if you want to access any web page by IP address, for example, 173.194.73.94, you could find it difficult to keep this thing IP address in your mind. But instead of using this IP address, if you use a name like google.com, so it becomes easy for you people to address and use this name, that is google.com. Then high level readable names were introduced. This is done in order to decouple machine names from machine address. In this way, company's web server might be known as a particular name, that is www.google.com, regardless of IP address. Network itself understands numerical addresses. Some mechanism is required to convert the names to the network address. Converting numerical address to names is known as domain name system. Normally, a network understands only the IP address, but for the user's point of view, we use the name to point out to a device. And there should be some or the other mechanism to map the name of a device and the name that is been given to it. So this mechanism is been done, or it has been provided by help of DNS. DNS is converting numerical addresses to names. Okay, and it is this methodology was designed in the year 1983. It is invention of hierarchical domain based naming scheme and a distributed database for implementing naming schemes. It is primarily used for mapping host names to IP address and for different purpose. Next topic, next slide. DNS namespace. Managing a large and constantly changing set of name is non-trivial problem. Example, if you take the address of any college, university, or a company, it is going to provide you for internet top naming hierarchy is managed by an organization. Considering the internet top naming hierarchy is managed by an organization called ICANNC, that is Internet Corporation for Assigned Names and Numbers. It was created in 1998. It is a corporation. It is a group of what you can say people, those who are coming, those who have came together, and they are looking after this naming space. Internet is divided into 250 top level domains. Each domain consists of many hosts. Each domain is divided into subdomain and it continues. Likewise, you can divide that domain again into subdomains, again into subdomains. In that way, you can have n number of subdomains of a main domain. The next slide name server. A simple name server can contain entire DNS database and respond to all queries. But in practice, this server would be so overloaded that it can become useless. To avoid this problem associated with having only a single source of information, DNS namespace is divided into non-overlapping zones. Now, what is mean by zone? Zone is nothing but it is a type of geographical location or the distance inside a network that is considered or that is decided by the zone administrator. How many servers should be present inside this uh, geographical or inside this zone, or how many computers should be present inside this zone? That is the everything is decided by the zone administrator. Normally, a zone will be will have one primary name server which gets the information from a file on its disk, and one or more secondary name servers which get the information from primary name server to improve reliability. Some of name servers can be located outside the zone. Okay, so it is an important thing that you have to keep in mind is related with the zone. The process of looking up a name and finding an address is called name resolution. When a resolver has a query about a domain name, it passes the query to a local name server. If the domain being sought falls under the jurisdiction of name server, such as, for example, if you take Aurangabad.Maharashtra.India, so now this Aurangabad is the subdomain of Maharashtra.India. Maharashtra is the subdomain of India. So in that way, okay. Now here, uh, a diagram is being given in front of you where an originator is there which is searching for a IP address on the network. So the query is being fired from the originator to the local name server. If that local name server is not having that IP address with itself, or the server is not at the local name server itself, it is going to forward that query to the root name server. Now, what is root name server? Root name server is nothing but it is going to have the what you can say, root name server is going to have the complete information of the main domains. Uh, Now, when the query is fired to the root name server, it is going to give you the nearest server address. Then again, it reaches to the local name server. After it is reached to the local name server, again it is diverted to the next subdomain part, subdomain address part. And again, the thing is going to be repeated till the complete address of that particular query that has been fired by the originator is been found. Okay, and the steps are being given in front of you in the diagram. Originator is nothing but inside this diagram. If you consider this diagram, flits.cs.vu.nl, it is the originator. It wants to find out an IP address. What is mean by local name server? Is normally it has a cached information about the domain available locally. It begins a remote query. Now, what is root name server? It is information about the each top level domain. Then you have root server could logically be a single computer, or entire internet depends upon the root server. These are powerful and highly replicated computers. Recursive query: when a host sends a query to local name server, namespace handles name server handles the resolution on behalf of the originator. behalf of the originator until the desired answer is there for the query. So this two lines are the explanation of this, how this IP address or the address is found. The next, what are the features of DNS? It is global distribution, data maintained locally and retrieved globally. DNS can be performed by any computer or device present inside a network. Scalability, there is no limit for the size of database. Single server can save near about 2 crore names inside it, and it can handle near about 24,000 queries per second, and it is done easily. Now, when I talk about queries, queries are distributed among masters, slaves, and caches. So this queries, data related to this query is being searched inside this master, slaves, and caches. Then you have dynamicity. Database can be updated dynamically. Modification of master database triggers replication. Now only masters can be dynamically updated. You have to keep this thing in mind, is only masters can be dynamically updated. Then the next feature is reliability. Data is replicated, and data from masters is copied to multiple slaves. When I talk about reliability, data is replicated. Why it is replicated? So that it is reliable. The data that is been stored or you want is must be reliable, and it is replicated. Means if any computer fails, still your data should be present. Then client will query to the local caches normally, and DNS protocol can use either UDP or TCP, so that reliability is been given or is been provided. Then loss coherency, database is always internally consistent. It changes to master copy of database are replicated. Changes to master copy of database are always replicated in all the copies that are being stored at different computers. According to timing set by zone administrator, cache data expires according to time out set by zone administrator. Okay, so today we have seen the topic of DNS. Thank you. Thank you, everyone.